Good morning. I am Dr. Sri Lakshmi, Assistant Professor ad hoc, working in Department of Mathematics, JNTUE College of Engineering, Anantapur. Today, I am going to deliver my lecture on system of non-homogeneous equations of the form f of d on y is equals to g of x, where g of x is any general function of x. In the last class, we discussed about the complementary function f of d on y is equals to g of x, where g of x is a particular case e to the power of ax, sine ax, or cos ax, or x to the power of m, or the function e power ax into g of x model and x into g of x. In this class, we are going to discuss a general form of the form f of d on y is equals to g of x, where g of x is not known to us. We can also solve this particular problem by using method of separation of variables. This is an extension. Now, we will start the concept. Already, we know the complementary function. So, directly, it is a solution of f of d on y is equals to g of x, where g of x is a function of x. Now, we know that f of d is a polynomial in d of the order n, where f of d is equals to 0 has inputs. They are alpha 1, alpha 2, alpha 3, so on up to alpha n. Therefore, if we want to write the particular integral of f of d on y is equal to g of x, this is equals to 1 by f of d on g of x. But f of d is a polynomial. It is of the form d to the power of n plus a1 into d to the power of n minus 1 and so on up to an is equals to f is equal to 0. So therefore, as we know that alpha 1, alpha 2, so on up to alpha n, the factors of f of d is equals to d minus alpha 1 into d minus alpha 2 into d minus alpha 3, so on up to d minus alpha n. Therefore, this is linear factor. So when it is a linear factor, we can use partial fractions to simplify 1 by f of d on g of x to the form a1 divided by d minus alpha 1 plus a2 divided by d minus alpha 2. So on up to an divided by d minus alpha n on g of x. Since a1, a2, a3, so on up to an are constants, 1 by d minus alpha 1 is on g of x. 1 by d minus alpha 2 works on g of x. Similarly, 1 by d minus alpha n is equals to g of x. Therefore, this is equals to a1 into 1 by d minus alpha 1 into g of x plus a2 into 1 by d minus alpha 2 into g of x plus a3 into 1 by d minus alpha 3 into g of x plus so on up to an into 1 by d minus alpha n on g of x. They are all of the same type 1 by d minus alpha I on g of x. We know that 1 by d minus alpha on g of x is a function of x. Let us assume that it is a h of x. Pre and post multiply this particular equation by d minus alpha. D minus alpha into 1 by d minus alpha on g of x is equals to d minus alpha on h of x. That is d minus alpha on h of x is equals to g of x. This is a linear differential equation. Therefore, on solving this linear differential equation, h of x is equals to e to the power of alpha x integration of e to the power of minus alpha x into g of x into dx. Therefore, we use 1 by d minus alpha on g of x is equals to e to the power of alpha x integration of e to the power of minus alpha x into g of x into dx, because my particular integral is nothing but sum of 1 by d minus alpha I on g of x, where I is equals to 1 to n. Therefore, we can write the total particular integral is equals to sigma I is equals to 1 to n ai into e to the power of alpha ix integration of e to the power of minus alpha ix into g of x into dx. This is very easy to find out the integration of e to the power of minus alpha x into g of x dx. Once we know this integration, automatically we can simplify to find out the particular integral. Already we know how to find out this complementary functions in my previous videos. Therefore, today I am going to start with one example based on this general particular integration. We will solve the problem d square plus a square on y is equals to tan ax. This is already, it is in the symbolic form. Therefore, its auxiliary equation is m square plus a square is equals to 0. Therefore, m square is equals to plus or minus, this is m square is equals to minus a square, or m is equals to plus or minus ai. This is of the form alpha plus or minus I beta. When the roots of auxiliary equation are alpha plus or minus I beta, therefore, my complementary function is equal to e to the power of alpha x into c1 cos ax plus c2 sin ax. Here, alpha is equal to 0. Therefore, when my complementary function for d square plus a square on y is equals to tan ax, or the solution of d square plus a square on y is equal to 0, is equal to e to the power of 0 into x into c1 cos ax plus c2 sin ax, or c1 cos ax plus c2 sin ax. Now, we know that the complete solution of this equation is equal to complementary function plus particular integral. My particular integral is equals to 1 by d square plus a square on tan ax. 1 by d square plus a square. Here, d square plus a square is having a roots plus or minus ai. So, d square plus a square is equals to d plus ai into d minus ai. Therefore, 1 by d square plus a square on tan ax is equals to 1 by d plus ai into d minus ai. Take the partial fractions because it is a linear equation, and this is equals to 1 by 2ai into 1 by d minus ai minus 1 by d plus ai on tan ax. That is equal to 1 by 2ai into 1 by d minus ai on tan ax minus 1 by d plus ai on tan ax. We have to find out this particular integral to separate terms separately. So, we will calculate 1 by d minus alpha ai tan ax. Here, 1 by d minus ai on tan ax is of the form 1 by d minus alpha on g of x. We know from the formula 1 by d minus a on 1 by d minus alpha on g of x is e power alpha x, integration of e to the power of minus alpha x into g of x into dx. Therefore, this is equals to 1 by d minus ai on tan ax is equals to e to the power of aix into e to the power of minus aix into tan ax into dx. We know that e to the power of I theta is cos theta minus e to plus cos theta plus sin I sin theta. E to the power of minus I theta is equals to cos theta minus I sin theta. On substituting e to the power of minus aix into tan ax dx as e to the power of minus aix is equals to cos ax minus I sin ax. We have this is equals to e to the power of iax integration of cos ax minus I sin ax into dx. But tan ax is equal to sin ax by cos ax. Therefore, the equation is equal to e to the power of aix integration of 1 minus I sin square ax by cos ax into dx. One is integrable. Now, sin square ax is not in integrable form because sin square ax by cos ax function, we have to simplify it. We know that sin square ax is equals to 1 minus cos square ax. But 1 minus cos square ax by cos ax is equals to secant ax minus cos ax. Therefore, this integration is equals to e to the power of iax integration of cos 1 minus I into secant ax minus cos ax. Consider cos 1 minus secant I into secant ax minus cos ax in the simplified form. So cos ax cancels out, leaving you sin ax. Take I as a common, then we have e to the power of minus iax minus I into secant ax. So on integrating this, this is equals to minus 1 by a minus I by a into e to the power of aix into log mod secant ax plus tan ax. But this is the particular integral of 1 by d minus ai on tan ax. Extending the same concept with 1 by d plus ai on tan ax because d plus ai and d minus ai are conjugates. Therefore, just simply replacing I by minus I in my previous particular integral, I have 1 by d minus ai on tan ax, which is equal to minus 1 by a minus I by a into e to the power of aix log mod secant ax plus tan ax. And 1 by d plus ai on tan ax is equals to minus 1 by a plus I by a e to the power of minus aix log mod secant ax plus tan ax. My particular integral consists of difference of 1 by d minus ai on tan ax and 1 by d plus ai on tan ax. So subtracting the both the things, I have in this equation 1 by d minus ai on tan ax minus 1 by d plus ai on tan ax. This is equals to I minus I by a into e to the power of aix plus e to the power of minus aix log mod secant ax plus tan ax. We know that e to the power of I theta plus e power minus theta by 2 is equals to cos hyperbolic theta. This is equal to minus 2 I by a cos hyperbolic ax into log secant ax plus tan ax. But cos hyperbolic I theta is cos theta. Therefore, this is equals to minus 2I by A cos AX into log mod secant AX plus tan AX. Therefore, my particular integral, which is equals to 1 by 2 AI into 1 by D minus AI on tan AX minus 1 by D plus AI on tan AX. This is equals to 1 by 2 AI into minus 1 minus 2I by A cos AX into log secant AX plus tan AX. But on simplifying this is equals to minus 1 by A square cos AX into log secant AX plus tan AX. Therefore, my complete solution, which is equals to complementary function plus particular integral. So, on adding this, my solution y is equal to C1 cos AX plus C2 sin AX, which is equal to minus 1 by A square into cos AX into log secant AX plus tan AX. Therefore, that is my solution. Now, my homework problems are of the same type. D square plus y square, A square on y is equals to cot AX. D square plus A square on y is equals to cosecant AX. D square plus A square on y is equal to secant AX. These three are your homework. Change different A's and find out the solution of this problem. Thank you very much.